So starting chapter 5, today we're dealing with triangles. Okay, some of this will be a review to you, but if you look on page 125 of your student journal, classify triangles in 3 different ways, by sides, and 4 different ways by angles. Okay, I want you to take a look at these. Okay, here it's classified by sides. Okay, we have scalene, meaning no sides are congruent. Isosceles, 2 sides are congruent. Equilateral, 3 sides are congruent. And then these guys down here, acute. We got 3 acute angles. Right triangle has 1 right angle. Obtuse triangle has 1 obtuse angle greater than 90. And equilateral, meaning all 3 sides are congruent. Okay, what I'd like you to do is these triangles up here, I want you to classify also underneath here. I just want you to say which classification for angles we would call each of these. Okay? Just based upon their looks. What type of triangle would this be classified by angle? What type of triangle would this be classified by angle? And what triangle would this be classified by angle? All right, Maddie Anderson. By angle, what would we call this one? Acute. All right, Carson. What would we call this one by angle? So would it be right? Would it be obtuse? Would it be equal angular? All equal. So only leaves acute. All are angle. Okay? And Cynthia, what would we call this one? Equiangular. That's a cool word. Equiangular. Very good. Okay? I want you now to classify each of these that are already classified by angle. I want you to classify them by side, by the look. Okay, I obviously know they don't have any side markings, but based upon what they look like, which we rarely do, but in this case we are. All right, secret agent Hale. How about this one? You think this one's isosceles? You thinking like this one and this one? Okay, so yeah, if you thought these two were congruent, it would be isosceles. I'm going to tell you they're not congruent. What would we call it then? Scalene. Okay. All right. Danica, this guy right here. Scalene. No sides are congruent. Okay, Alex, this one right here. Scalene. Oh, man. All pretty boring here. And Brian. Equilateral. All right, all sides are equal. Okay, so equiangular, all equiangular triangles are equilateral, and all equilateral are equiangular, just so we know. All right, any questions there? Okay, go ahead and turn the page real quick. Look at those theorems. Tell your neighbor which theorem you've used the most of. 3 theorems there. Okay, which theorem have we used the most out of those 3? Yeah, Jeremiah? Yeah, the triangle sum theorem. We've called it the triangle angle sum theorem. All angles of a triangle add up to 180. Okay, we know that. The exterior angle theorem is an interesting one, though. It says that, hey, if we know this and this, these two, let's say I look at this angle, and I'm just going to call it angle 2 for now. Okay? A, B, and 2 have to add up to what? Good. Measure of angle A plus measure of angle B plus measure of angle 2 equals 180. Everyone agree? It's really blurry. Okay? It's even worse. Let's try that again. All right. What do 1 plus 2 have to add up to? Okay. Nathan, what's 1 and 2 have to add up to? Yeah, 180. Okay, and if that's true, I know that this equals that. So I know measure of angle A plus measure of angle B plus measure of angle 2 equals measure of angle 1 plus measure of angle 2. Everyone agree? Okay, if that's true, I can take this piece off of both sides. Okay, that means measure of angle A plus measure of angle B equals what? Measure of angle 1. This plus this has to add up to that. Okay, it's always the case. And the last one, corollary, says that, hey, if we have a right angle, then the remaining angles have to add up to 90 as well. Tell your neighbor why that is. If you have a right angle, why do these two have to add up to 180 or 90? Just kind of gave it away. All right, Carlo, what do you think?
Well, a triangle has to equal 180 if you only have a right angle in it, and the other two have to equal the other half of that.
Good. Yep, triangle has to add up to 180, so if you already have 90, the other two have to add up to 90. Okay, any questions there? Okay, take a look at page 127. I want you to work on page 127 with your groupies right now. Okay, off you go. I know a lot of you don't have your protractors with you. I'm not going to get them out for this. Number one, it's pretty easy to tell if it's acute or obtuse. Number two is a little tougher to tell if it's acute or obtuse or right. I would suggest, if you're not sure, use the corner of a piece of paper to see if you have a right angle there. Okay? And then you could just use, like, for number 4, if you want, you can use one of the grids off of our warm-up page to graph that. Okay, so number 1 goes to Brendan. You get to come up and do number 1. Number 2 to Maddie Jacobson. And number 3, Drew Pauly. All right, remember, if you get called up, you can bring someone with you. Off you go.
I'm sure I spelled that wrong. How do you spell sausage? Huh? How do you spell sausage? No, there's an O, jeez. It's I-S-O-S-C-E-L-E-S. Say that again real slow. I-S-O-S-C-E-L-E-S.
It's recording this, Brendan.
It's been recording for 8 minutes. Yeet. I know. Can you shush me? I know. Just making sure you know. That's it. Make sure I have.
All right. Well, here we go. Number 1, scalene obtuse. Very good. Yeah, it's obtuse angle right here. And it's scalene, no sides are equal. Okay, so we mark that like that. Okay, a right scalene, then no sides are equal. Very true. However, is that a right angle? Yeah? Double check. I'm gonna, not that I don't trust, but I'm just checking.
It is not.
Ooh, that looks, I don't know.
It's not.
It's just a little odd. Looks like it's obtuse. Very close, but I think it's obtuse. And this one is isosceles because two sides are equal and three acute angles. Isosceles acute. Okay, very good. Any questions there? Okay, number 4, you could use one of the grids off your warm-up sheet. It may help you out. Or you could just use the distance formula on each of those points. It's up to you. Okay, number 4, if I graph it, this is the guy I get here. I did a quick sketch. When I do that, I ended up with a scalene right triangle. The way I knew it was scalene, first, all sides were different lengths. I used the distance formula or the Pythagorean theorem on each of them. But then second, the way I knew it was right, once I found the lengths, you can use the Pythagorean theorem, a squared plus b squared equals c squared. And you find out that square root of 32 squared is 32, square root of 18 squared is 18, and square root of 50 squared is 50. Okay, 32 plus 50 equals 50. Therefore, Pythagorean theorem works out there. The scalene right. How many got scalene right? How many got scalene? How many got right? Hey, that's right. Good job. Okay. Make sure you're asking me if you have questions as they come around. Try 5 and 6 and 7. Tell them what you got for number 5 and 6 there. Okay, angle 1 is equal to this plus this, right? Yep, so this is 160 degrees. Okay? Number 6, we know that this plus this adds up to that. So 40 plus 5x plus 15 equals 8x minus 5. Okay, ends up giving me 5x plus 55 equals 8x minus 5. Got variables on both sides. I'm going to collect the variables on one side, so I'll move these x's over, so that gives me 3x. I'll move this 5 over, that gives me 60. So x equals 20. And it says find the measure of the angle, so I know x is 20. Don't stop there. 8 times 20 minus 5, or 160 minus 5, or 155. That is our solution. Any questions there? All right. Number 7, in a right triangle, the measure of one acute angle is twice the sum of the measure of the other acute angle, and 30. Find the measure of each acute angle. Tell your neighbor what you got. Not a lot of talking there. It's a word problem. It's scary. Anyone have a plan of attack on this? Break it into thirds? Okay. Well, it's a right triangle. That gives me 90, right? 90 plus another angle plus another angle has to add up to what? 180. Okay? The question is, what are the other angles? So in a right triangle, the measure of one acute angle is twice the measure of the other angle and 30. So let's call one acute angle. Okay, what are we going to call? What do we call one of those angles? X. There we go. In a right triangle, the measure of one acute angle, there we got it, is twice the sum of the measure. How do we say twice 2x? Twice the sum of the measure of the other angle and 30. 2, we've got to find the sum first and then add 30, or then double it. So it's 2 times x plus 30. So it's twice the sum. Sum means you have to add two things together. The sum of that other angle and 30. Okay. So there we've got it. We've got 90 plus x plus, what's this become? Good. Equals 180. Okay, how many x's over here? 3x, how many units? 150 equals 180. What's 3x equal? Equals 30, and x equals 10. Okay, if x is 10, one of my angles we already know. We know x is 10, so another angle is 10. What's this third angle? That's 10 plus 30 times 2, which is, it's 80. Okay? The other way to think about it is all these have to add up to 180, so it's 80. Third, got it. So the measure of each acute angle would be 10 and 80. I guess that's what it's asking. All right. Okay, if you have questions individually, make sure you ask me today. I'll give you your assignment here.